All right, you guys should be good to go.
Cool. Who wants to go
Go
first?
first. I'm happy to. I haven't been here in a while, so
Cool.
cool. So I think it must have been like a month ago or something. Showed the concurrent schedule replication. So this is the CBC variant that you know, um, I guess only orders things that need to be ordered. Hopefully, or at least something like that. And it was kind of in this like weird state where the fork choice works sometimes, but not always. And spent some time discussing with Vlad, and pretty much like realized I was doing things totally wrong, and they were way more complicated than they had to be. But anyways, sorted that all out. So I can screen share real quick. Um, Ignore the desktop. I'm embarrassed. But anyways, the concurrent protocol, that's what I'm calling it, but is working at this point. So essentially what that means is we can have, a block that has multiple parents, let's say, or multiple ancestors. So it might be kind of hard to see. This is kind of a busy graph, but you can see like this block, for example, is building off of this one and this one, hence the two previous lines. Yeah, so there are a couple outstanding issues with it. You can see we've got this block building off of 3 now. Anyways, let's try it for the screen share. But there are a couple issues with it currently. First, we kind of just have like random rewrites going on. But in general, it's possible to extend them. It's like totally extensible to like, whatever rewrite rules we want, I guess. And then also the second issue is that I'm having a bit of trouble writing a safety oracle that's not like horribly inefficient. Or sorry, the safety oracle's written already, but like for the safety oracles to work, you need to implement a method that tells essentially lets you know if two blocks conflict with each other. And I'm having a bit of trouble writing that for some reason. And it seems to be that it's kind of this confusion between like creation of outputs and blocks themselves, and kind of like they're almost the same thing, but they're not exactly the same thing. And so for that reason, writing an oracle isn't as easy as it maybe should be. But
are they not the same thing because multiple outputs can appear in the same block?
Yeah, exactly. Yeah.
So would it be easier to add a restriction that you can't have more than one output per block, or does that just ruin everything?
Yeah, it seems like it would be, but like I wonder if we want to do that. Like I think it probably would be easier to write the oracle if we restricted it to a single output per block. Like or like consuming and one block consumes one output and generates another output, but we might lose some generality with what the proto can actually do. And so I don't know if I want to do that. At least that's my fear.
Yeah, that's fair.
But so Vlad kind of likes the idea of like identifying, I guess what he calls the frontier, is essentially as like some set of outputs, and kind of just ignoring the fact that there's even blocks in the first place. But the issue with that is then like, figuring out when things are finalized, et cetera, gets kind of very strange, at least in the way everything's implemented as of now. So because that kind of makes this protocol very different from, the other ones we have so far. But anyways, yeah, that's all for me. Thanks.
Cool. That's quite interesting, actually. It suggests that maybe concurrency is a little bit different.
Yeah. So okay. So here's an interesting thing. I think it's possible to implement this function, right? So it's like the conflicts with function, right? To see if two blocks conflict with each other. It's possible to implement this in a way that gives us like what I think is like an extreme lower bound. So like for example, in blockchain consensus, two blocks, they don't conflict if one is in the history of the other or something, right? And I'm pretty sure we can say the same thing for like the concurrent schedule, right? But the thing is that we'd actually prefer to. The thing with that is that that's actually a bit of a lower bound, right? Because just because two blocks aren't in the history of each other, it doesn't mean they're conflicting in this case, because they might be consuming totally different sets of outputs, right? And so that's kind of where the issue is. If that makes sense.
Mhm.
So it maybe I'm phrasing wrong in terms of it's actually maybe not that hard. It's just that implementing one that isn't like super low to a super lower bound is like different. It's definitely different.
Yeah, understood.
Could there be a way of improving the performance if you stored results? Like instead of recomputing every single time, you, I don't know, have like memoization basically.
Yeah. I think like memoizing would make things a lot more reasonable. Yeah, definitely. Because like if a block doesn't conflict with another block at one point in time, then it never will. And also if a block in your history, like the only block that's your ancestor doesn't conflict with the block in the other block's ancestry, like immediately, then that's also good to know, because that tells you that these two don't conflict with some conditions. So
yeah, exactly. Set it up as some kind of like memoized recursive function, and that maybe would be.
Yeah. I have a comment. It's actually a comment to do memoize to make this more efficient. But yeah, I'd love to actually chat about that with you at some point. So
Cool.
Good suggestion. Cool.
Hey, this is Rick.
Rick.
Just hey, what was the start of that? I guess I missed the most vital 2 minutes of all time or something.
Pretty much that I have implemented a working version of like the concurrent schedule replication, which is pretty much like let's say generalized block DAG rather than just like the blockchain, right? So it's like you can have multiple kind of, each block can kind of point to multiple parents as long as they don't conflict, if that makes sense. So, and we were just talking about the intricacies of detecting safety with that kind of data, with those data structures.
Yeah. So yeah, that is really difficult, I guess. Especially and then what's in the blocks exactly? Is it justifications? Is it like
So each so each block has they have their justifications as usual, but their estimate, which is maybe the most interesting change, is like it's essentially tuples of like a previously unsped output and a new output. And this child is essentially a block. This block is essentially a child, of each block from which it spends an output. Right. So if an output's generated in block A, and then later some other block comes along and includes some output from block A in the first part of its tuple or one of its tuples, then it's a child of block A. If that makes sense.
Yeah. Sorry, this might be a really basic question. When did we start talking about UTXOs? When did that happen?
Yeah. That's a great question. I guess a month ago.
And what was the argument for doing that?
Just that it's a useful thing for kind of building this. Yeah, I don't know. They're not actually UTXOs as of now. We're just pretty much like rewriting integers, but I think the idea is that they could be.
I feel like UTXOs have a lot of problems. I mean, I thought one of the few things design decisions I did like about original Ethereum was not using UTXOs. So
yeah, I think I'm probably not the best person to ask about this. I think Vlad's talked about like this could be applied to UTXOs, but there's also a way to generalize it to like straight up accounts and state. But
yeah, because I think there's actually an answer here in that the UTXO has a genesis, right? The UTXO has a history. So I guess what I'm trying to understand is, you talk about the blocks, but the UTXOs in the blocks actually you would know that those two UTXOs, for example, if it's literally a UTXO with a history of just its genesis in two blocks, and you know there's no conflict if that's all that's in the block.
Yeah, I hear you. Yeah, I haven't thought much about like the UTXO history itself, but that's a good point. Yeah, I don't know. I'll talk to Vlad about like adapting this for a non-UTXO model if that's even a thing. But I'm pretty sure he's at least mentioned that. So
Yeah, because I think if you're creating the accounts, and I guess that's the other thing, right? If are we using an account sort of tree model like in existing? Yeah, I mean, I think I think you do have to inspect a little bit inside the block of the the content of the block to determine. I mean, maybe this is obvious to everyone to figure out the conflict, right? So
yeah, I think
the,
that's true.
the different types of data in there, I mean, obviously have a pretty big impact on how you do the conflict resolution. And if it's, when you first, because I jumped in the middle, it seemed like at first I thought you were talking about arbitrary state changes, that, two different two different blocks have two different transactions that mutate the same value in a smart contract, right? But if you're just talking about UTXOs, then, if you're examining the UTXO, it's actually fairly easy to determine if they don't have the same, if they don't immediately come from the same previous output, then any modification that they would do would be additive, right?
Sorry, you lost me in the last part. Why do they necessarily immediately have to come from the same output? I mean, at some point in time, that's true, but couldn't there, have been a chain of mutations, right?
Between two UTXOs. So I have two UTXOs that are split. It's because they share a parent, but it has to be because if they share a parent or an antecedent greater than their parent, then wasn't that parent also confirmed, or are we looking at long chains?
Oh, no. Yeah, we can have like arbitrarily long chains of unconfirmedness. So yeah.
Right. And so then the only way to detect the conflict is to decompose from those blocks the actual chain of the UTXOs and see if they share a parent or not.
Yeah, so effectively the UTXOs carry some notion of justification, which is a part of. I think that's why this abstraction was chosen. You're gonna have to have a conflict model for every kind of thing that you're trying to get consensus on in this setting. It's not going to be like some of the others because you actually have to be able to say formally what it means to conflict. And UTXOs, you have actually a fairly simple idea of what it means to conflict, which involves the history. That's the meaning, and anything else is going to be a lot harder.
Yeah.
Okay, I see. Yeah, I see where you're going with that. And then I guess this is sort of the iterative process that we're going through in Casper, because before we were talking about bits, right? So now we've evolved, we're an amoeba walking out of the water to UTXO, and then we're going to end up at arbitrary state. Is that the idea, or are we going to be doing?
I mean, so I think like, the blockchain, for example, probably could do arbitrary state. Just maybe we get some scalability gains if we can do arbitrary state in the current schedule. At least that's what Vlad has like mentioned in the past.
So, I mean, if you look at the proposals that I have on the table, first of all, I have a very clear notion of what transaction is. Transaction is an IO pair, right? That IO pair is governed by a notion of name that has structure, and so you now have a logic which can talk about the structure. So you have logics which can then determine where you have conflicts. So that gives you massive improvement, scalability, because now you're only you can deal with as many transactions as you want, because the formulae denote the sets of transactions or collections of transactions. And then if the formulae evaluate to empty or absurdum, then you've got a conflict somewhere. And so you have to negotiate, and you can negotiate at the level of formulae by dropping constraints. A simple example is this transaction has to occur before B, and B has to occur before A. So that denotes the absurdum. There's nothing in the interpretation of that formula. So, and those are the only two constraints that you're arguing about. One of them has to go.
Yeah, and so I guess that was quite, I had some vague understanding of that stuff already, and so I'm confused as to how we ended up talking about UTXOs. Because what's the mapping between that, the Rolang stuff, which has inputs and outputs, and the UTXO stuff? How are those being reconciled?
Well, I think Vlad's argument is that his abstraction can map over lots of different consensus algorithms. So so they're looking at just a wide variety of different value domains and different kinds of settings over which they're getting consensus. And we're in the Rolang setting, we're kind of just going for the gold, right? We have a clear notion of transaction, we have a clear notion of what we're achieving consensus over, and because of the way the namespace structure is articulated, we can get compression by using formulae. So that's a very focused and driven, like, I'm trying to achieve this one goal thing, and Vlad is looking at consensus in a more general fashion.
Yeah, but couldn't you still use, so I guess just to confirm if I'm understanding this, so you could use Casper to be the consensus engine for that Rolang stuff, right? I mean,
Well, absolutely, and that's what we're doing.
yeah, I mean, that seems like that would be much easier actually than than trying to get consensus. Okay, I get it. Okay.
Yeah, absolutely. Yeah. So, I mean, to be honest, I'm trying to put some structure on this in a couple of different ways. So, first of all, uh, the current articulations of Casper, the axiomatizations are a bit ad hoc, right? So it's hard to know precisely when and where the axiomatization begins and ends. Like, why is this all the axioms you need? Would be a driving question. And what's the relationship between the axiomatizations and the class of consensus algorithms that you can cover, right? So those are questions that are outstanding in my mind, at least with respect to Casper. So in order to give some structure to this, that's why I've gone to the far extreme and said, okay, look, as near as I can tell, the traced monoidal axiomatization is about agreement across a lot of different things, not just consensus, but it at least gives us a decent notion of consensus. And then from there, and it's highly motivated in terms of where the boundaries are for the axiomatization. We know precisely why the axioms, like the yanking axioms and the vanishing axioms and all of those axioms for the trace monoidal construction exist. Every single axiom is justified. So then, and more recently, what I've shown is that we can give a kind of constructive interpretation. So starting from the cup and cap style presentation of the trace, I can give a very, very concrete reduction of that to what we think of as message passing algorithms. Now, from there, we should be able to line that axiomatization up with CBC Casper. So in other words, CBC Casper as an axiomatic framework should slot in underneath trace monoidal axiomatization, and then hopefully that gives us a handle on this zoo of algorithms that we might cover, because now we can say how the CBC axioms are related to the extremely well justified axioms of the trace monoidal construction. So that kind of gives us the order. Otherwise, it's just like it's a free for all. Well, let's do byte ball. Let's do hashgraph. Let's do Paxos. I mean, when does it stop, and why do we care?
Yeah.
So, but if we can say, well, look, there are these 8 axioms. Here they are. If I get rid of this one, we stop being able to express that. If I get rid of this one, we stop being able to express this other collection of algorithms, right? That gives us a little bit of order and structure, and we kind of go, we know why this algorithm is essential or must be captured by this set of axioms, right? It gives us a set of monkey bars to traverse the playground with.
Yeah. Okay. Yeah. Thanks. Thanks, guys. That helps a lot, actually.
Sure. Michael, you had some interesting updates.
So last week I spent longer than I expected, honestly, putting together Byteball as a CBC Casper variant. As Greg just referenced, as the beginning of the zoo of protocols that one might express in a CBC way. And I guess like the main takeaways from it, I would recommend everyone read it, or at least scroll through it a little bit to see sort of if you have any feedback for me or anything along those lines. Basically, the main takeaway that I think comes from it is that it's expressing things in terms of a total order, right? Which is something I don't think we've seen in other CBC variants before. And so it has a nice safety oracle to go with its total order, and everything sort of revolves around these special users that are able to sort of define the order using how their blocks are in the DAG relative to other blocks. So basically they take the role of validators, which is a concept that we've seen before. So it's interesting to see it applied to this total order setting. The other thing that I really like about it is anyone can create a block, not just validators. And I think that's huge in terms of scalability, because now all of a sudden we're not limited by the hardware of a few big players, because anyone with enough hardware to compute their own block can send it out. And as long as they can do
Michael?
Is he gone?
need, then you're golden.
You cut out there for almost 30 seconds. Can you say the last little bit again?
Sure. Sorry. I was just saying that letting anyone create a block is huge for scalability. I think that's a great feature that this particular variant has that we haven't seen before.
I'm sorry, which variant is this?
So Byteball is an existing crypto blockchain thing. Basically, it has an internal cryptocurrency, but its main, I guess, selling point, if you will, is that it's a blockchain database. So you can, the use case that it gives is basically you can have the blockchain as being a way to sort of give proof that some piece of data existed at any given time. So say you have some piece of data, you take its hash, store it in the blockchain, and then in a month, if someone asks, how do I know that data existed a month ago and that you didn't just invent it just now, you can say, oh, well, look, there's a block with the right hash.
And how is that mapped?
So are you in the Casper Discord server?
Yeah, I am. I can't look at it right now, but I'm there. Yeah.
Well, so I posted the CBC Casper description of Byteball. You can also look up Byteball and look at their original white paper. My only complaint about it is that it's very wordy. They don't use any equations and very few pictures, and so there's just paragraph upon paragraph explaining how this works.
Right, but I mean that was a pretty terse question. I mean, how do I find the transaction? How do I find the hash in the block? It could be in any block. Is that just mapped in a relational database?
That's okay. Okay, yeah, I see what you're asking. Yeah, that is a good question. The short answer is I don't know. I think basically what you would do you can search by block hash. That's their web portal does that actually. So if you're the person who's trying to supply proof, you would, after you make the block, keep the block hash locally, and so then when someone asks you for proof, you just send them the block hash, and then they go look it up themselves.
Cool. Yeah. Okay. I get that. I mean, I'm doing some BFT DB work myself. It's interesting that someone decided to do it that way, but yeah. I generally think if you have something where you're saying anyone can make a block, well then how does that block represent a canonical global ordering? Right, it by definition does not. It's a semantic thing, but like everyone else calls their global canonical ordering a block, and if you call your not global, but somehow canonical ordering a block, that's fine, but it's super confusing.
Fair point. In their original nomenclature, they call the things that users create units, and they don't use the word block anywhere, actually.
Okay, cool.
So users create a unit, and units are ordered into this total ordering based on their position relative to witness-authored units, where witnesses are these special users that play the role of validators.
So
right,
Michael, this is my first exposure to Byteball. Is it cross-chain? Is it cross-blockchain? Is Byteball?
You mean, can I sell Byteball stuff for ETH, for example?
Yeah, that, but also their architecture says that they're not a blockchain, but a DAG, right? So
that's right, yes, they're a DAG.
If they're a DAG, I mean, technically, are they able to cross blockchains and allow people to put whatever transactions they want to on there, or?
I think the answer to that question is yes. I do know there are exchanges that support trading their native currency, which they call bytes. But I didn't look too closely into those technical details, to be honest. I was just focusing on taking their description of the protocol and translating it into a CBC Casper description, since the idea behind Casper is that it's generic, right? You should be able to take most consensus protocols and map it into a CBC framework. And so that was the work that I focused on, and rather than sort of the technical implementation of it.
Okay, so these things that aren't blocks that they're creating, if I want mine to become canonical, I pay a transaction fee to a witness, and then it becomes canonical. Is that correct?
No, you pay your transaction up front. So going back to our discussion about UTXOs, it's very UTXO based. Basically, you need to provide enough inputs, unspent inputs, to your block to pay the fee required to create the block. And so this is where their currency nomenclature is cute, because their currency is called bytes, and the amount of bytes that your block is, like its physical size on disk, that is the amount of currency that you have to pay. So it's sort of this cute one-to-one relationship. So you have to provide enough inputs to your block to pay for the fees. And then when you do that, as long as it's a valid block, any other node will see it and pick it up, right? So it's immediately canonical in that sense, But what you have to wait for is if you were trying to do a double spend, for example, you have to wait for the order to become final, and then the first block in the order is the canonical one, and any conflicting block that comes later is considered invalid and not used.
Okay, so they're not called blocks. What are they called again? Sorry.
Units.
Okay, so I create a unit. I have to spend outputs or TXOs to create the output, and then assuming that I did that in a valid way, other nodes that are not witnesses pick up this unit and then include it into the DAG. Am I understanding this correctly?
That's right. Yeah.
All right, and then a witness has to basically seal that part of the DAG before I can then spend the UTXOs that I created in that process. Am I understanding that correctly?
That's right.
Okay, so the DAG is running. This sounds a lot more. This sounds almost like graphene. So the DAG, anyone is adding heads to the DAG, but only the quorum of witnesses can make those heads canonical.
Correct.
And if I choose, I can add on to my own head, but logically no one else would until a witness, or unless they trusted me, or right?
Well, so you can create blocks constantly. A witness doesn't need to come and do anything to your block. Everything is about the structure of the DAG itself. So really all witnesses need to do is post blocks consistently and include any block, any head of the block when they do post. And essentially, as long as they're doing that, that is enforcing a total order. And they honestly don't care what's in any of the blocks, because once that total order is enforced, everyone agrees on the order, and the finalization is quite quick. Like you don't need to wait for a witness to go inspect your block.
No, yeah, I'm not understanding that. That's where I'm confused. It's not that the witness wouldn't be inspecting anything, but the witness still has to verify that the block is valid, that there's some validity in terms of the TXOs.
No, because they don't care. You can try to double spend as much as you want, but if your double spend comes later in the order, everyone's going to ignore it. No one's going to recognize that as a valid block.
So then there is only. So how is there a DAG then? If I basically for a stream of UTXOs, there's a head that is canonical because a witness signed it. I'm a little confused as to how you can have your description here. I'm missing something. How does a witness? Why does someone trust my block that I created not as a validator? Well, I didn't have to do any work. I didn't have to do proof of work. I didn't have to bond. I didn't have to do anything. So why does anyone trust that?
They will trust it after it's finalized. That's the trick.
Okay, so what's the finalization process?
The finalization process is all about this ordering. So once your block is deep enough in the DAG, it can be ordered relative to every other block.
And so what makes it deeper?
Because more people are adding on to the DAG on the end. Like they build on top of your block.
So someone else sees my unit and then they somehow reference my unit in their unit.
Yeah. So parent-child relationships have nothing to do with the content of any block. Parent-child relationships are in some sense arbitrary. Like as soon as I see a block without a child, my new block should always point at it.
And so what if I just withhold? What if I give you a UTXO to spend that I have withheld all the blocks from? So let's say I took a block, a unit, let's say I took a unit that I created a week ago. I mined on top of my own unit, and then I gave you the transaction to spend, and the week's worth of blocks between your your payment and the last time that UTXO touched the network. What do you, how long does it take you? What computation do you have to do to spend that output?
I'm not totally sure I followed your example, but I think what I'm gathering is that if you're withholding from the network, then you're not getting deeper into the DAG, and so your block isn't getting finalized, and so no one's going to trust your block.
Right, but why wouldn't they? But there's no way to reconcile that. That's a partition. I just.
Oh, I see what you're saying. Gotcha. Yeah. So I guess you would, as soon as it reappears in the network and people start building on top of it, eventually it becomes deep enough in the DAG to be finalized. Like, that's the key thing is that it needs to be around and observed by enough of the network for a long enough time that it ends up deep enough in the DAG that its order can be final, and then people trust it.
Yeah, this doesn't sound any different than, I mean, the fact that anyone can submit a block and a unit in quotes. I mean, those are just transactions, right? I mean, that's why I didn't want to use the word block, because you just described to me a transaction to a T. You have to describe and the finalization happens as these witnesses do whatever sealing on those transactions, and they just never form blocks. I mean, it's just transactions without blocks.
Yeah, that's exactly how they describe themselves in their document, that there are no blocks, only transactions.
Yeah, okay. So yeah, to call those transactions blocks is really, 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 really confusing.
No, they don't call them that.
Okay.
Yeah, they call them units. I was calling them blocks to try to draw the parallels to.
Yeah, but they're not blocks. That's the whole point. They're not blocks. They don't do what blocks do at all. They don't provide any sort of global order. But anyway,
right.
Okay.
That's fair. I'm happy to change the nomenclature in my little write up there for sure. Do you think that unit is a good name, or should I just always call them transactions?
I mean, there's a unit seems to be a transaction container that is not a block. So I would not call them blocks, because they don't have the ordering properties of blocks, which is like the most important thing about a block.
But you're happy with the name unit? You think that's a good name?
Yeah, unit gets the job done. You know.
Okay,
Well,
cool.
the desideratum to consider is, like, in your write-up, you have to show that you have a faithful representation of their algorithm, which seems really hard given that their algorithm is not actually formally presented, right? So it becomes very
well. They do have open source code, and so that's what I was mostly using.
So the code is the spec, okay?
Yeah.
Right. So
and I was using their white paper, but like I said, their white paper is very wordy.
So if there's a bug in their code, then there's a bug in the protocol.
That's the nice thing about formalizing it, right? If you can write a proof in the formalization, then you know it's correct.
Yeah. Okay. Anyway, just with respect to nomenclature, your nomenclature needs to facilitate mapping back to their stuff as well as mapping forward to the Casper stuff. Since that's
totally. Yeah, that's a great bit of feedback. Thank you. I appreciate that.
Yeah, and thanks for taking the time to clarify all that. I appreciate it.
So the one thing that I mentioned this to you in email, Michael, but you know, the thing about the Casper CBC framework currently is that the logic is a creative step. You have to invent the logic, and that seems a bit silly since we have this logic manufacturing algorithm. You know, that Mike and I have spent a great deal of time proving for now an extremely broad class of logics.
Yeah, I agree. I replied to your email this morning.
I saw your reply.
Yeah. So I would love to see what a modified version or an updated version of Casper looks like, where we're applying ladle to get the logic instead of using it as an input. I think that'd be great.
Yeah, it just seems like a natural, and then you don't, there's no creativity at that step. If you have to have creativity at that step, that means that these algorithms are never going to be, automatized or systematized, or, you're not going to be able to turn, like with a minimal amount of inputs, turn a handle and get a CBC out, right? Which would be ideal.
Totally.
Yeah.
I'm maybe demonstrating how far behind I am in the literature. I need to catch up. But where could we read about the ladle algorithm? Where can we find stuff? Is that on the RChain wiki or?
Yeah, for sure. We have tons and tons of papers about it at this point. We're working on a submission to major conference, so we can get you a draft of that.
Cool.
The algorithm is really straightforward. You start with a spec of the domain of values over which your logic operates, and ideally this is a domain of programs, right? So some kind of rewrite system, and then you start with and by the way, that invariably means you've given it as a monad. So what we've said is, hey, for a wide class of these, your monad corresponds to a Levier theory. So there's a nice set of results that say these kinds of monads are Levier theories, these kinds of algebraic theories are monads, right? So there's a correspondence. And so, and you're probably, like, if you looked at this format of a Levier theory, you'd probably go, oh, I see how I could encode most interesting data types this way. So basically the idea is the structure of values over which your formulae denote collections of, that's going to be given by some data type, and that data type turns out to be a monad. Now the other piece of the puzzle that you need to have is you need to have a collection. So like a set or a list or a bag or a graph or a tree, and it turns out that all of those are also monads. And more recently, what we've said is that in the case where you're dealing with certain infinitary collections, like you'd like to be able to talk about, the set of all even, or the collection of all even numbers, or the collection of all odd numbers, or things like that. So obviously certain kinds of infinitary collections are useful and interesting to talk about, especially when you're talking about collections of programs. There you need some apparatus that's a little bit more expressive. And we've kind of given a rational reconstruction of topos theory, which you can think of as kind of like how to do set theory just using categories. So we've given a rational reconstruction of that only using monads. So rather than having to have all this extra topos theoretic apparatus, which basically sneaks in logic on the side, which would be very unsatisfying, because basically what we were saying then is, in order to explain logic, we have to have logic to begin with. That's not as pleasant a result. So here we can give a kind of rational reconstruction of the important bits of topos theory just using monads. So then effectively what we've said is the domain of values is given by a monad, the notion of collection is given by a monad, and the desideratum from logic is Curry-Howard and realizability. So Curry-Howard is going to say that, there's this nice lineup. Your proofs in the logic should correspond to programs, and theorems or propositions should correspond to data types, right? So that kind of nails down the orientation of your logic. And realizability says that the meaning of your formulae should be the collection of all the witnesses for the formula. So so if you're saying that a particular so the meaning of a formula in this particular setting would be all the programs that enjoy the property encoded by the formula. And once you have that, then those two desideratum, it completely nails down the logic you can, the shape of the interpretation of the logic. So you end up with basically the logic has to be a distributive law or be determined by a distributive law. So which basically says your formulae are going to be in one-to-one correspondence with collections over values or collections over terms. And then the semantics or the meaning of the formula will be in one-to-one correspondence with sorry, I said that backwards. The formula is going to be given in terms of terms over collections. So think about, being able to write a program, but you knock a hole in the program somewhere, and you say you can fill this hole with something that meets this specification. So that's your notion of formula, and then the notion of the meaning of the formula will be collections over terms. So all the programs that fit that sort of meet that spec, meet that formula, and then you can prove that you always have such an interpretation. That since you have some equations on what monads can do, and you have equations on the distributive law, the semantic map always exists. You can always construct that thing, which means that you get soundness for free, and under certain mild conditions, you get completeness. So the type systems or logic so generated are automatically sound. So
Cool. Super cool.
So
Thanks for the intro.
Sure, it's super pleasant, very nice results. It basically says this is what a logic is for every logic that I've ever seen proposed, from modal logics to Hennessy-Milner logics to spatial logics to, unless they're like really, really wacky logics. This covers anything you might want. So then it seems very natural to say, hey, don't just pull something out of a hat for Casper. Just, calculate it.
Yeah, cool.
Greg, if you want to, I don't know if you are in the Casper Discord, but if you want to post a draft there for people to read, that would be good. Or if you're not in there, email it to me and I'll post it there.
I think I'm in there. Vlad sent me an invite. The first one, he sent it while I was traveling, and I couldn't click on it until it expired. But I think I clicked on it before the second one expired. Otherwise, just invite me and I'll join.
Cool. I'm not sure if I have admin rights to invite you, but I'm sure someone does.
All right, cool. Is there any more updates?
I have a question. Is anybody in the group focused on cross-blockchain issues or cross-blockchain consensus? Can any of this thing that Greg was just describing, can that be used for cross-blockchain, assuming that there are problems with each of those blockchain of certain degree? I mean, the consensus problem can perhaps be the same or thought of cross-blockchain as being some of these things are untrustworthy and some are more trustworthy, whatever it is. Is that possible, or is anybody focusing on that? Because I think that's going to be a major issue.
So the short answer is yes. That's one of the principal motivations for the trace monoidal axiomatization of consensus. So even if you begin from a network that has a homogeneous consensus algorithm, over time you want to update the algorithm. I mean, almost certainly the community is going to have, soft forks and various updates to the algorithm, which may not roll out over the network uniformly. So even if you just begin with one algorithm, over time, you're going to get a heterogeneous network. And what you'd like to be able to do is to prove that in these networks where you have heterogeneous consensus algorithms, that you have some kind of end-to-end consensus that makes sense. And there, it would be really, really nice to be able to say up front what exactly a consensus algorithm is. Like right now, there's no proposal apart from the trace monoidal proposal that I put on the table that says, hey, if I hand you an algorithm, do you have a decision procedure whereby you can test to see if it's a consensus algorithm? And I've got exactly such a test on the table, right? And that was sort of the point of the presentation I gave around Christmas time was, I can, we start with this trace monoidal characterization of consensus. We can give a faithful interpretation of that into the row calculus, and then from the row calculus, I can derive using ladle a type for what is considered a consensus algorithm. And now, at least if you always give me an implementation of your consensus algorithm in row, I can go and type check that. And if it type checks, then I know for a fact it's a consensus algorithm. So then we know that it meets certain axiomatic requirements, and we can reason about end-to-end correctness. Now, there's still a lot more to be done, but that's a beginning. Does that answer your question?
Yeah, thank you.
Cool. Well, this is a rich discussion.
Yeah, thanks for a great stand-up, guys.
Yeah. Talk to you guys next week, if not before.
Sounds great.
Thanks
Bye.
again, Chris.
Yeah, take care, guys. Later on.
See you guys.
Later, guys.